my statisticians? This is Professor Sampson from PS I Love Math, back with another statistical banger. Today we're going to move into a new chapter called Discrete Probability Distribution. And we're going to start talking about random variables. So sit back, relax, grab yourself a cup of wine, and don't forget to like, comment, and subscribe. What's good, my statisticians? In the intro, you saw that we're going to be doing discrete random variables. So we want to start that off with a few definitions that may be helpful to you for learning how to do discrete random variables. So let's check them out. So we're going to go through a couple of important definitions that you'll need to work with discrete probability distribution, and in this particular section, discrete random variables. So the first thing we need to discuss is a random variable itself. Random variable is a variable whose numeric value is determined by the outcome of probability experiment. What that means is that you need to get an answer from your probability experiment, and you choose some kind of variable to represent that particular value. So the probability distribution is a table that gives the probability of every value of the random variable x. So in your probability table, you'll be getting every value of that random variable x. So whatever the possibilities are, that's what you'll be given in that table. And usually your tables are things you're going to be winning and things you're going to be losing. So that's how your table may be set up most of the time, but we'll see. The next definition we want to work with is properties of probability. Oh my God! The next thing we want to talk about is properties of probability distribution. Right? There are two properties that are important for probability distribution throughout the rest of this chapter. Number one is all probabilities are between 0 and 1. And this is an important one because students be writing anything for probability. Right? Probability is a number between 0 and 1. That means that you can't write a percent unless they specifically ask you what percent in the question. You can't write a percent. You can't write a whole number other than 1 or 0. You can't write anything. And oftentimes students forget that when they write their answer, and they'll put all percents or whatever numbers they come up with. But remember, probabilities are numbers between 0 and 1. And the other property of probability distribution is that the sum of all probabilities is equal to 1. So that means that when you add up all your probabilities, you should get 1 or close to 1. Remember, the world is not perfect, so you may not get 1 exactly on the dot, but you will get something close to 1, like 0.998 or something of that nature. But you can't get like 0.97 anything because that's not close enough. So make sure you're careful with that when you're doing your problems and they ask you, is this a probability distribution? It needs to be really close to 1 for that answer, for that to be true. And the next definition we're going to cover is the discrete random variable. Now, discrete random variables have either finite many possible values or infinite many possible values, and these are all determined by a counting process. So what does that really mean? That means that your discrete random variables are countable numbers. And when you say infinite, we don't use the infinite ones, we use specific ones, but they can have infinite many possible values. Okay, so they can have any type of values that come up that you can come up with. They are determined by the numbers in the counting process. That's what a discrete random variable is. Remember, if we go back to discrete and continuous, we learned that a couple of chapters ago. Discrete means exact, whereas continuous means going on after the decimal, which next chapter will cover continuous random variables. But anyway, these are discrete random variables, which means they're going to have an exact number. So they're kind of easier to work with if you know that they're going to have exact numbers, that your random variable x is going to be a whole number. It sort of helps you work out the problems easier. So I've been doing a lot of talking at you because I already had these definitions already pre-written down for you so we could get it started a little bit quicker. So let's get into something now. Now we're going to get into what we call expected value, because that's what we need to really talk about in this section. Expected value is just that. We call it capital E parenthesis, capital X parenthesis. So the expected value, the value that we expect the random variable X to have on average, okay, on average. So what we would expect, you know, when you're doing something, you always have an expectation of what's going to happen. So that's what our expected value is what we expect to happen. But the good thing is that the expected value, when we're talking about average for discrete random variable, is equal to the mean of the probability distribution.
I have no idea what you're talking about.
The expected value obviously is an average, so it's equal to the mean of the probability distribution. So let's write that down just to have it down. So the expected value now, we don't really use the formula. We use our calculator, hence for this formula, but just so you know that there is a formula for it. And we'll do it by hand before we do it by calculator. So we have our expected value, that's a capital letter X, is equal to mu. Remember mu? All right. That's the mean of the population. And that's going to be the sum of your X, whatever it is, so we call it X of I, times your probability of that specific value of your random variable X. This is the formula on how you get it. So we'll take a look at a couple of examples on how we get it and how we use it. But what does this say? This says that our expected value is equal to the sum of our X of I's times our probability. That's all it's saying. So when you get your X of I's and times your probabilities, and that sum, you'll add up all of those and you'll get your mu. But before we jump into the examples, I just want to show you a couple of more of the formulas just in case you need them. These are the formulas. So if you wanted to find the variance of a discrete probability distribution, that's going to be equal to the sum of X squared times the probability of that specific value of X. One's a uppercase and one's a lowercase, and then minus mu squared. Different textbooks write this formula differently, so you might see it a little different in your textbook, but it doesn't matter. They're the same thing, just written differently. And of course, we know that the standard deviation is just the square root of the variance. So we just took the square root of that. So I can title this the formulas for a discrete probability distribution. So if you can't read that, that just says the formulas for a discrete probability distribution. So you have the mean, which is the expected value, you have the variance, and you have the standard deviation. So those are the three formulas. So let's jump into our example. Okay, so here's our first example. I love this example. One of my favorite examples I love this example. One of my favorite examples is the insurance company example. An insurance company offers Mississippi adults between the ages of 25 and 34 a $100,000 life insurance policy for $18 a month. They use the fact that Mississippi has a yearly death rate of 172.8 per 100,000 residents aged 25 to 34. So let's get started. A is find the expected value. So forget all that. What they're saying here is find the expected value per customer for the insurance company. You have to figure out who you're trying to find the expected value for. So we're talking about the expected value. So I usually tell you mine's W. I like W. I use W for wins. Who's getting a win? So if they charge you $18 a month and they want to know about at the end of the year, so they're charging you $18 a month. So that'll be, first thing is 18 times 12, right? So 18 times 12 is 216. So that's the first thing we do. So for them, a win is 216. So they would get $216, the insurance company. Or what would they lose? Well, if the person died, they would have to pay out a $100,000 policy. However, that's not what you get, because you always have to take out the amount of money that you paid into it. It would be that $100,000 policy minus the 216. So what the company actually is paying out is $99,784. So they would be paying out. So for them, that's a loss, negative $99,784. So the next thing is this probability of an X if it's a specific X value. Well, they said in the example that the death rate, 172.8 per 100,000. That's the death rate. So that's if they die. So let's change that over to something we can work with. So 172.8 divided by, I think, 100,000. So 0.001728. So they're going to have this loss this percentage of the time, because this is when they die, they get a negative, and this is the death rate. Well, if somebody lives, then they get the difference. So the difference is 1 minus this stuff up here, 998272. Now I can either put it in my calculator or I can do it by hand. I'm probably going to do both of them. So it's going to be that W times that P, the probability of that particular value. So I would take the 216 and multiply it by that 0.998. Again, this is if I'm doing it by hand. And then I have that 99784 negative. Make sure you put the negative down here. 99784. That's how much they lose times. So now I have my two numbers. Now I'm going to multiply these two numbers. I'm going to multiply the 216 times that 0.998272. And that's going to give me 215.63, right? And it's money, so I'm just going to put 215.63. Then I'm going to multiply this negative 99784, and I'm going to get negative 172.43. When I add these together, I'm going to get the expected value. So I'm going to have that. And my expected value is $43.20. So to answer the first question, my expected value of X is $43.20. That's how much the company makes on the policy. Part B says, if the insurance company has 10,000 customers with these life insurance policies in Mississippi, what is the profit at the end of the year? So that's simply going to be just the $43.20 that they make on each customer times 10,000 customers, 432,000. So now you see why they can afford to give out those life insurance policies, because their expected value each year is in the positive. They get 10,000 people paying this much. With that being the case, let's just put this in our calculator. Again, I have to show you both calculators. So we would go to our regular place, stat and edit. We would put in our numbers. So we had 216, and then we had negative. If you have the 84 plus CE, if you have the 84 plus CE, from this point, you can do this. Now, my 83s and my older 84s can't do this. But from this point, you can do this. You guys can go into stat and you can go over to calculate and one variable statistics. In here, you will put line 1, list 1, and then under frequency, you would put list 2. This is only if this screen pops up for you. If it doesn't, I'll show you what to do next. And you hit calculate, and then it will calculate for you as you see 4320. 4320 is the sum of the x's. Use the sum of the x's, right? 4320 is the sum of the x's. Okay, let's say if you didn't get that screen and you have the 83 or an 84 that doesn't get that screen. You still do the same things in L1 and L2. L3, you're going to go over and do the multiplication like we did it by hand. So this is virtually doing it by hand using the calculator. So instead of me putting in all those numbers. So I would just tell my calculator to do L1 times L2. You go up on top of L3, you put in L1 times L2 and you hit enter. And as you see, remember these were the same numbers, right? So now that you have the numbers in L3, now you can do an evaluation on L3. So now you can go to stat, same place you would go calculate. Now your thing is going to pop up one variable statistic, right? It's not going to pop up this screen. It's going to pop up the screen that says one variable statistics. When you see that screen, you're going to put right next to one variable statistics, you're going to put L3. In my calculator, I'm just going to put L3 in this list. Again, if you already did it the other way, you don't need to do it this way. So remember, you'll get up one variable statistics, and then next to that, you'll put in L3. Once you do that, then you'll hit enter, and then it'll give you this. Please use the sum of the x's. That is not the appropriate mean. Remember, it's taking the mean. When you do it this way, it's taking one variable statistics of line 3, which means it's taking the mean of line 3. That's why you can't use the mean on this one like you can on the newer version. You would use the sum of the x's, which is 4320. The sum of the x's, which is the answer that we got when we did it by hand. Is that, hopefully that stands with you and that stays with you for the two different calculators, and especially if you have the 83 or an older 84. You know, if you have an older 84, where if you go into stat and you go into calculate and you don't get this screen here, have the older 84, even though it's an 84 plus, It might be an older 84 where you have to do the other way. And we're going to go on to one more example. Okay, so let's go ahead and do the second example.
Damn!
Scott likes to trade stock online. On a good day, he averages $2,200 gain. On a bad day, he averages a $1,600 loss. Suppose that he has good days 25% of the time, bad days 35% of the time, and the rest of the days he breaks even. What is the expected value? So I'm looking for my expected value. So this is what I'm looking at. And I'm looking at the expected value. I go right ahead into my, as I call it, my win-lose chart, so to speak. So what does Scott have to win? Well, he has to win $2,200. And what does he have to lose? He has to lose $1,600. So his probability of the win-lose thing of his on a good day, his good days are 25%, which a probability is between 0 and 1, which is 0.25. But on his bad days, he has 35% of the bad days, 0.35. Now, the reason that I don't put any more days here is because on the other days, he breaks even. So his win-lose would be 0. So 0 times anything is going to be 0. So that's why you don't have to put it here. Just so we can get another feel of putting these numbers in. L1 times L2. So those are my two numbers, 550 and negative 560. I could have gotten those by multiplying in my hand. See how we can use the calculator. And we actually know our expected value is equal to the sum of that. So 550 plus a negative 560 is obviously equal to a negative 10. So our expected value is negative 10. Let's check that out on my calculator. And L2, and you never had to put in L3 if you had this calculator. And as you see, you go by the sum, which is negative 10. You had the other calculator and you went in the stat, you would go in to calculate, and then right next to one variable statistics, you would put in L3, right? And you see right there, negative 10. The question was, what was the expected value? So we already have that really quick for A. Let's move to B. That Scott trades online every weekday for 3 weeks. How much money should he expect to gain or lose? Times 15 days that he traded, negative $150. So it says, how much money would he expect to gain or lose? The answer is he would lose $150. C is fun. Now, C is the variance. Now, the calculator won't give you the variance, so please don't try to go to what I taught you before, VARs and all that stuff. Remember from what we wrote before, the formula for the variance. That's where this comes in. Okay, if you're asked this question, you need the formula for the variance. Formula for the variance that I gave you was sigma squared. The variance was equal to the sum of your x of I squared times the probability of your x, right, and then minus mu squared. Where you have your mu, remember mu is just what? Right? Recall that mu is the same thing as the expected value. Mu is equal to the expected value. Now look, this is not the sum that we had before. Why? Because this is squared. So we do have it. It's cool. We have it in the calculator already. So let's go back to our calculator, and however you get there, stat calculate. Okay, so if we go back, now this is the difference between the older 84s, the new 84s, and that's difference where there's a distinct difference in the calculator, so you have to do more work. So if you have current one, the one that I'm looking at, you look right here and they give you the sum of x squared. So they give this to you right here, 2,106,000, right? Right here. That's the sum of your x squares. And then you would subtract your negative 10 squared. You get your correct answer. The issue is this is one of those situations where having the other calculator doesn't necessarily play well with you. What is the variance for 1 day of Scott's online trading? This is the correct answer. However, the issue is if you have the 83. This is one of those times where you have to do it by hand. Remember, the recommended calculator is TI-84 plus CE. And yes, you can use the 83 or the 84 plus, or you can use anything else, but that doesn't mean that you'll have the easy access like you normally would with other calculators. So in order to get this answer, see, just so you can see, it doesn't work for the 83. So if I had went here, remember we had L3, you had to put in L3. That was the only thing you could put in. So the calculator couldn't take into consideration your frequencies. You don't have that number. This is not the right x squared. This is not the right sum. So you can't use this number here. So what you have to do, if you have the 83 or not, or you don't get this with your 84, you really have to do the formula by hand. You would have to do this formula by hand. You would have to take 2200, square it, and times it by your 0.25. Negative 1600 squared times 0.35. Get what that is equal to, because it's the sum of these things, and then subtract it from your mu. So you'll see you'll get the same thing, but it requires you to do a different set of work. So let's do it. 2200 squared times your 0.25. Your 0.25, and then you have to put it in parentheses, negative 1600 squared times the 0.35, and then you add these together, and you see you get the same thing that we got, 2,106,000. So once you add these together, you get the same 2,106,000. So you do have to do the extra steps if you don't have the newest calculator, but that's going to be a couple times in this stat class. Just so you know, if everybody's okay, well, you might not be okay with it. But there will be a couple times if you're using the TI-83 or the older 84 versions that you have to do more steps than somebody who has the newest calculator. I do have a link down to it below if you decide that you want to get it, and it is over $100, but it may help you in the long run. So if you want to do it, click down on my link below and it'll take you there. You can buy whatever color you want to buy. This is Professor Station. I love math.